Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. This reaction involves the alkylation, acylation, of an active methylene compound, malonate ester, under basic conditions using sodium metal, followed by acidic workup with ACOH. Moving on to the next step. Identify the starting material and product. Starting material, CH2, co-2-me, 2-dimethyl malonate, which has two ester groups flanking a CH2. Product, CH, co-2-me, 3-trimethyl methanitricarboxylate, which has 3 ester groups on a single carbon. Moving on to the next step. Determine what transformation is needed. The starting material CH2, co-2-me, needs to gain one additional co-2-me group on the same carbon. This means one of the two H atoms on the CH2 is replaced by a co-2-me group. And for the final step, mechanism with Na and ACOH. Sodium, Na, deprotonates the active methylene of CH2, co-2-me, 2pK-13 to form the stabilized carbanion enolate CH, co-2-me, 2-. This nucleophilic carbanion then attacks an electrophilic carbon source that can introduce a co-2-me group. Evaluate each option as the electrophile. A. CH2, co-2-me, to another malonate ester, not electrophilic enough at carbon to react with the carbanion under these conditions. This would not introduce a single co-2-me group. B. Co-2-me, 2-dimethyl oxalate, would introduce an oxalyl group, not a single co-2-me group directly. C. Cl, co-2-me, methyl chloroformate, ClCO2-me, this is an acyl chloride with a methoxy group. The carbanion of dimethyl malonate attacks the electrophilic carbonyl carbon of ClCO2-me, displacing Cl and introducing the co-2-me group onto the carbon. This gives CH, co-2-me, 3 after workup. This is a straightforward C-acylation reaction. D. COCl2 phosgene would introduce a COCl group, not a co-2-me group, and would likely give a different product, could react twice. Why option C is correct? Methyl chloroformate, Cl co-2-me, is the correct electrophile. The sodium enolate of dimethyl malonate attacks the carbonyl of methyl chloroformate, and after ACOH workup, the product is CH, co-2-me, 3. This is a classic C-acylation of an active methylene compound. Why others fail? A. CH2, co-2-me, 2 is not electrophilic at carbon under these conditions, no leaving group. B. Co-2-me, 2-dimethyl oxalate, would give a different carbon framework. D. COCl2 phosgene would not directly give the trimethyl ester product. Therefore, the correct answer is C. Therefore, the correct answer is option C.